Let's look at Netflix Gaming and see if we can find some interesting things in the way they make use of WebRTC. And remember, we're looking at cloud gaming this time.
So Netflix is doing casual games in their cloud gaming service, unlike other services like GeForce Now and the xCloud, who are very performance-oriented. This is more casual games, so lower bitrate requirements, and we will see that as well. I captured that 2.5 minutes from my Windows machine, very smooth session, everything looked good, and we'll see some interesting things here.
Okay, and this is incoming only because it is cloud gaming. You're not sending anything, you're just getting the rendering of the machine running in the cloud of the game itself.
Yes, some cloud gaming services actually ask for audio, but Netflix doesn't because their games don't support audio. They're not multiplayer games, or at least the one I played isn't a multiplayer game.
Okay, and we see a low kind of an observation that says that there are empty I servers, so there are no stun or turn servers here.
Yes, I mean, for cloud gaming, you want a UDP connection and you want to actually fail instead of going over TCP. So that's a very common pattern.
Okay. Anything else interesting that we can find on the connections themselves here?
What I found interesting was that the DTLS connection time is merely 18 milliseconds, which is quite low, which is because Netflix is probably running this on their edge servers. So very close to the user.
Okay. The other thing that I saw, by the way, is that they use IPv6, or at least your machine used IPv6, which also isn't that common with many of the WebRTC services that we bump into.
Yes. I mean, in other services, we still see IPv4, but this one is IPv6, which is good.
Okay. Let's go to streams.
So we have incoming audio and video. Let's look at the video, which is more interesting.
Okay.
If you go to bytes, and what we see here is two things. First is forward error correction is used, so FlexFAC or ULPFAC. FlexFAC is more common for game streaming services. And we see that there are different phases. So it starts out with slightly below 2 megabits per second during the loading screen. Then there is some phase where it's like the bitrate isn't that stable. And then it actually ramps up to 8 megabits per second, which is the target they have. If you look at the frames, we can see it's 60 frames per second, and we have, where do we have the resolution? Under quality, I think. Yes, go to frame width. Yes, so it's 1280, 720, which for cloud gaming is low, but for the casual game, it made total sense.
Yep, so 720p resolution at 60 frames per second.
Yes, still good quality.
Okay. And then there are no devices because it's only incoming, there is no outgoing. And in the logs, the only interesting thing that we want to note is the munging part.
Yes, so it does some munging on the audio, and we will actually see, we point that out. This is adding stereo equals 1 to the local description. That's a way to tell Chrome to enable stereo playout of received packets. Why you have to change the local description for that, nobody understands, but it is the way it is.
Okay, so come check rtcStats.com and what we're doing to analyze our own service.